Hello and welcome to Mathssteps. Today we are going to learn how to calculate using standard form. In my previous video, we learned how to change numbers from ordinary form to standard form and vice versa. Here we are going to learn how to make calculations, so how to add numbers presented in standard form, how to take away, how to multiply or divide them. It's all to make the calculation with numbers in standard form a lot easier and more effective. So what I've done here, I have created a table with steps. So to add standard form, these are the steps we're going to follow to subtract, to multiply, and divide. Now, I'm going to explain all the steps one by one using examples. Right, here is the first example. So we have the addition of two numbers expressed in standard form. So we have 6.2 times 10 to the power of 5 plus 3.5 times 10 to the power of 5. Now, as you see, both standard form, the powers, the indices are the same. And I'm saying here, if they're not the same, make the indices the same. So in this case, they are the same, so we don't have to change them. So all we need to do, we need to add the numbers in front. So 6.2 times 3.5 make 9.7. So 9.7, so add the numbers, leave the indices as they are. So 9.7 times 10 to the power of 5. We don't add the indices, it's just like that. All right, it's quite similar to when we do, for example, 2x times to the power of 5, okay, plus 3x to the power of 5, plus 3x to the power of 5. So imagine you think of x to the power of 5 as it's an object. So same object, so 2 plus 3 is going to be 5. So 5x to the power of 5, just like that, is the same as the same strategy, same thinking. When you add standard form numbers with the same power, so just add the numbers, leave the power as it is. Let's have a look at the other example. Again, here we have the subtraction of two numbers with standard form, and the indices are the same. So all we have to do is just take away the numbers in front. So it's going to be 6.2, take away 5.3, so it's going to be 0.9 times 10 to the power of 4. All right? No need to change the power. Next example. Now here we have two standard forms where the indices are not the same. So one is 10 to the power of 3 and the other one is 10 to the power of 4. So what do we do? Now you can either change 10 to the power of 3 to the power of 4 or change 10 to the power of 4 to the power of 3. Now I would advise you to change the biggest indices to the smallest indices. So write this one to the power of 3. So how do we make this change? Now we can rewrite 10 to the power of 4 as 10 times 10 to the power of 3. Can you see? Which means we multiply 4.7 times 10. All right? So 4.7 becomes 47 times 10 to the power of 3. And the next one is the other number, 3.9 times 10 to the power of 3. And there you go. Both numbers are expressed in the same indices. But this one, of course, is not a standard form, but we express it like this to be able to add to the other numbers because the powers are the same. So if the powers are the same, now we simply add 3.9 plus 47. And so the answer is going to be 50.9 times 10 to the power of 3. And if the question says express the answer in standard form, then 50.9 is not a standard form. So we're going to have 5.09 times 10 to the power of 4, because 50 is bigger than 10, and we need this number in front to be smaller than 10, bigger than 1. All right, next example. We have now here a subtraction of two numbers that both are expressed as a standard form, but the indices are different. This one has the biggest indices, so we are going to change this to the power of 4. So as this one becomes 10 less, so we're going to have times 10 to the power of 4, then 7.3 becomes 73. Okay, so this one becomes 10 less, 10 times less, the number in front becomes 10 times bigger, to keep the value of the number the same. All right, the next one exactly as it is, times 10 to the power of 4. So what we do now, we subtract the numbers in front, so we're going to have 73, take away 5.4, and the answer is going to be 67.6 times 10 to the power of 4. Okay, but is this a standard form? It's not, because 67.6 is bigger than 10. So this one becomes 6.76 times 10 to the power of 5. So, and this is in case the question says, write the answer as a standard form. This is how we do it. Next example. Again, both numbers are expressed in standard form, but be careful here because it says minus to the power of minus 3 to the power of minus 4. So which of them two has the highest indices? Of course, it's minus 3. So we change minus 3 to minus 4. So this is the high. So as this one becomes 10 times bigger, so this one becomes 10 to the power of minus 4. So the the highest becomes the smallest. Okay, so as this one becomes 10 times smaller now, this number here becomes 10 times bigger. So this one becomes 59 times 10 to the power of minus 4. Okay, minus 4.7 times 10 to the, we don't need the bracket here. Some 10 to the power of minus 4, bracket should be in the end. Okay, right. So 59 take away 4.7, 59 take away 4.7, and the answer is going to be 54.3 times 10 to the power of minus 4. Okay, so the only maybe challenge would be when you deal with negative indices. So remember, the largest negative indices is the one with the smallest value. Okay, that is the largest one, because 1 is 3 is bigger than minus 4. So we changed the largest to the smallest indices. Minus 3 to minus 4, so 10 becomes 10 times bigger, so it becomes 10 times smaller, so 5.9 becomes 10 times bigger. That's the best thinking to be able to remember to convert. So the final answer, so this is the answer, but to make it into the final answer, which means to change it to a order, to do it standard form, then we're going to have 5.43 times 10 to the power of minus, so this one becomes 10 times smaller, this one becomes 10 times bigger, minus 3. Okay, just like that. Now, but how do we multiply numbers in standard form? This one is much more straightforward. So we multiply the numbers, says you don't have to change the indices in this case. It doesn't matter if the indices are different. You multiply the numbers in front, add the powers or add the indices. So 2.4 times, so we have 2.4 times 3.2, the answer is going to be 7.68. So 7.68 times 10 to the power of, now add the indices, 5 plus 3 is 8 to the power of 8. Just like that. And this is actually expressed in standard form because 7.68 is smaller than 10. And the next one, division, the rule is exactly the same. We divide the numbers in front, but instead of adding the powers, we're going to take away the powers. Take away. So divide the numbers in front, take away the powers. So 2.4 divided by 3.2, it is going to be 0.71. I'm going to write the whole answer as it is, 7. So 71875 times 10 to the power of 5. Take away 3 is 2, so times 10 to the power of 2. All right, and bigger than 1, so we can to change this into a standard form, the number is going to be written as 7.1875, okay, times 10, just 10. Just 10. We can simply write this as an ordinary form because it's not, the power is not very large. So this one would be 71.875. There you go. So you can write it like this, or 10 to the power 1 here, but it's still times 10. So yeah, these are all the rules of multiplying. So of multiplying, dividing, subtracting, and adding. So remember, we have to change the powers. Or on these indices, how we call them, only when you add or subtract standard forms. If we multiply and divide, you don't have to change the powers. Just add the powers if you multiply and multiply the numbers, or take away the powers if we divide and then divide the numbers. So remember, you need to learn these rules off by heart. The rules are similar actually to when we use x's and y's in algebra. Some multiplied terms with the different powers, like terms with different powers. Right, so thank you very much for watching Mathssteps. Here we have some independent work. You have multiplication of two different standard form numbers, two different examples, and here you have divisions. And yeah, thank you very much for watching Mathssteps. Have a lovely day. Bye-bye.